a lot of the hacks today are through SQL injection. And he's going to talk more about it, but I'll let him talk a little bit about himself and about SQL injection, which has been around for a long time, and we still can't get rid of it. So please welcome Jesus for me. Thank you.
Hello, everybody. You guys can hear me okay? Hope so. I'd like to know my audience, so before I introduce myself, can you guys get a few show of hands? How many people in this room are programmers or want to be programmers for one aspect or another? How many here are more, just don't know anything about databases, just kind of get an idea of what SQL injection is? One of the problems that we have in, I think, in the educational system is that we do try to teach kids, whether it's C++, whether it's Java, whether it's some programming language, very few are exposed to the database part of it. The database part of it is where SQL injection fits, but it is most vulnerable because it's lack of understanding how the database works. Most of you guys, when you get your first programming job, are kind of, you get it because of your knowledge of Java, because of your knowledge of .NET, because of your knowledge of C++. And once you get the job, they'll throw a database at you, and many times you just make it work, and that's all that matters. I've been doing programming now for 15 years. I've done it from Foxtrot to DBase to to Sites, Oracle, Microsoft SQL Server, MySQL. It's a database at one point or another. I've worked on it, one project or another. And most of the work that I got as a contractor was going back into old applications that worked and fixing the SQL part. Not the application part. The application part for the most part was okay, but fixing the SQL part that was exposed. How many of you guys have actually built a database or worked with a database before in the past? So you will understand the basic concept of how we communicate with a database, which is nothing more than SQL commands going from your code to your SQL server, to your database. Yes? So if all you're sending is string commands, then SQL injection is very simple. You know, if you can get any application, whether it's web or any kind of application, and you can manipulate the input that you give it and have that application pass it to your database, you can have a SQL injection. So all you're actually doing is you're trying to convince the database to do something on your behalf through the application you're running in it. Because almost everything we do now is on the web. The biggest place we see attacks is in web applications. It doesn't have to be a web application. As long as the application can connect to the database and send a command on your behalf, you can compromise it. Right, for this particular session, we're talking about web applications and how they're going to be able to get in. But how is it that we can get data from the database, from the user input to the actual database? Well, you have query strings. How many of you guys have actually seen me play with the query strings that you get on top of the browser? You can just sit there and just play with it. Sometimes they give you paging, you go just screw with it and see what you can do. Well, many times there's no validation for those parameters. You also have forms. Forms are a little harder to attack because you're constantly reposting versus a simple get and a query string. But you can easily manipulate the input because unlike a query string in which there is a limit to how long the character is, so it's, if you figure out that you can compromise a particular application because you're limited to how much text you can physically send in a query string, you're limited to how intelligent you can be and how you can pull the data back out. That's not always true in a form. In a form, you can actually are limited only to what the actual GUI programs, in which you can actually submit a whole gigabyte, a whole 2 or 3 megabytes worth of input in there. So you can type in a lot of code to do a lot of damage if you do through form-based attacks. Headers, some applications now are actually using headers to try to pass information. Anytime that code is taking, whether it's from a header, query string, or form, is being sent to the database, if you can find a way to manipulate what is being sent across, you can find a way to exploit the database. So here's an example of what your basic scenario would be when you want to attack. You have a user somewhere on the web, and they're going to hit a website. And that website is going to prompt for some kind of information. It's going to have a scripting engine, or whether it's Java server pages, whether it's ASP.NET, PHP, that's going to try to separate the user input from the application. And it's going to try to take that user input and it's going to try to send commands to the database. As it sends data to the database, normally speaking, it's going to pull back a list of products, a list of users, a list of available classes to take. If you can somehow pass, if the person that wrote the application doesn't know how to talk to databases, doesn't understand the concept of cleaning input, they might as well just take the value you gave them and pass it right along. Well, that's great, because now if you want to attack the database for your behalf, if there's no validation, and if they want something like a number, you can pass in a number, dash, dash, make a comment, and any kind of command you want to give it. An example. Let's say that you have an application that selects a list of users from a given database. You're an administrator, or you have a particular application that allows you to see a list of users to create users. So the basic syntax that you would actually embed in your application would be something like select everything from users where the username is blank, and that blank would be the parameter that's being passed in from the user. And the password is blank. Once again, I am prompting you for that username and that password, but instead of putting in an actual username, what I actually did is I have a single quote here, so I passed in another single quote there. What that's going to do, it finishes the statement and then passes an OR statement. That allows me to bypass the actual validation of what the user is. It just says, give me everything where 1 equals 1. So since you didn't validate my code, that's going to translate itself in the actual database to select everything from user where blank or 1 equals 1. And the extra dash dash that I put here, it's going to make the rest of the syntax nothing but a comment. So now that allows me to log in regardless of what the username, what the password is. So you immediately say to yourself, well, no, you're not going to just take any kind of valid user input as a valid input. You need to scrub it. You need to clean it. So let me give you a few examples of what you can do to try to mitigate the possibility that you're going to get in crap and just send it right across. Before I do that, let me cover this real quick. If somebody is able to find a flaw in your code, in your application that you wrote, so what? Not all applications are built just because you can exploit just a little bit of like passing a few commas. So you can play with my app and make it break, so what? It doesn't really give you a value. Not necessarily. If I can find a way to compromise your app and I can send some information to SQL, especially if that application is running under some elevated privileges, I can get access to not only the application itself, get access to information that I'm not supposed to get access to, list of all the grades so you guys can modify your scores, but I can actually change the schema. So I can do simple things like drop table. If you drop table, all of a sudden all the information you've been collecting in your application for the last 3.5 years is gone. And if you don't have a good backup, you pretty much have to rewrite that app because you lost all your data. If you are running that application on the database portion of it, has enough permissions, you can actually have it shell out to the command prompt and run a program. One program that I wanted to show you guys, but I thought with the internet it would be nice to show you, I didn't want to gamble on it, is I can actually shell out on a command if the actual execution of the SQL is running under SA. I can shell out to a command prompt and open up a netmon back out to the internet. And so they can actually ping my own address, tell me where you're from, and open up a session so I can send you code to run. So not only are you making the SQL Server expose itself to some kind of damage to the database, you're actually exposing the server in which the database is running. So that's a nice trick to show, to scare the crappers out of somebody, in which just by a couple of SQL injections, you opened up netmon to connect back to you, to connect back to it, to be able to take over the box. All because you allowed SQL injection. Denial of service. I just don't like you. Therefore, I'm going to just drop your database. Not 1 or 2 tables, but the whole thing. Well, if I drop your database, you're pretty much down to the restore cycle that you're at now. Depending if you have enough privileges on how you actually set up the database, I can actually tell SQL Server to go read files off the disk for me. Select me everything from // etc/sys users. Give me a list of all your usernames and your passwords that I want. So it is a vulnerability, and because many times when you do the initial install of SQL or any database for that matter, it does require elevated privileges. The actual process is running with enough privileges to do a lot of damage to the box itself. So if I can compromise the SQL box, I can compromise your box. The basic web application that I was planning to show you guys was a basic web application, nothing more than a username and a password. So in the prior example that I showed you, in which I was passing in a username and a password, and I physically would type in the name of the user that I want, close it out for 1 = 1. What I'm trying to do is I'm hoping that you haven't validated that input, and if you haven't validated that input, and you send that literal value over to the database, I can log in as any user that I want. It won't even check for the password, which just let me in. The database that I want to show you guys, the one I've been playing with, is Microsoft's database here. Just to give you some sample. Does anybody know how to connect to the database if you do not know what the name of the database is for SQL? 3 points, come on, I'll give you $1. If you put a dot, nothing else, you can connect to the local database that's running on that box. You don't even have to know the name of the box. So that allows you to quickly get into something. So once again, if you're trying to attack a box that's not yours, you don't always know what the name of the box is. Dot. I'm going to show you this only so that a few other students can see a few things. So you have a basic server, a database engine. What's the purpose of a database engine? The purpose of a database engine is to take any command you give it, process it, execute it on your behalf. So something as simple as creating a database is not that complex. All you have to do is tell it, create database, test, execute, and if you do that, nothing else, you can create a database. It's not that hard to create a database. You can send a command to create a database. About creating a table. All right. All I want to do is create a table. I can say, all right, inside the test database, all I want to do is create a table for a username and a password. Simple idea. What I'm trying to show you is that the whole database engine that is running, whether it's an Oracle database engine, a SQL database engine, a Sybase database engine, all they're really doing is taking any command you give it, and if it's proper syntax, it's going to execute it. And it's going to execute it on the context of the current user. So at this point, I have one database that I just created for you with one table. And there's the columns that the given table has. Now what I want to show you. Here's the store procedure. It's using something called dynamic SQL. Dynamic SQL simply means I am not going to separate the code from the actual data. Whenever you do not separate the code from the data, you're guaranteeing yourself the possibility of interpreting data as something as part of the program. Mind you, SQL, all it does is takes a string and parses it and executes it. If you can separate what the code is, the select statement from the parameters away from it and tell it, no, the parameter is data, don't try to parse and identify what's in there, but the content, the code, is this. If you can separate those two, your exposure to the SQL attack is not as high. This is what I call bad code because the person that wrote this one actually said, you know what, I'm not going to take advantage of the fact that it's a stored procedure. I'm literally going to just take some parameters in, dynamically execute the select statement that I have in here. Most of the time that when you experience applications out in the field, a lot of the code that you see is either buried like this or it's buried inside the application. Because the application has to get data from and send to the database. And many times your middle tier, your web application, is not the database server itself, so it's going to actually have a lot of embedded SQL statements inside the app, and it's just sending over the command with parameters to do something. So if you normally think, okay, this is a basic SQL statement, and I'm just basically going to pass in a parameter, I am now going to try to test it and say, okay, what if I pass in for a specific user with a specific hash for the username? Well, if you use it properly, supposedly, oh, this proper works fine. I can call it, I can pass in a parameter, and I can get my user information. There's nothing wrong with this application. The store procedure does what it's supposed to do. Well, what if I tried to attack you? What if I passed you that information in which I commented out the username and I gave you a password? When you do that, let me try. Is that big enough for you guys to see? What I'm doing that here is, you see how I put in 2 commas there? I mean, 2 single quotes? What those 2 single quotes are going to do is they're going to try to close off this quote right over here. The or sign, sorry, the or condition and the 1 = 1 is going to make it so that this where clause is true, and the rest of whatever is there, doesn't matter that it's there. I just told it comma, comma. Anything after 2 dashes for SQL server is considered a comment. I could also put in / question mark. I also could have put in a hash sign. Different databases have different ways of sending comments. But what you've done there is you turned around and you trick SQL to say, the data that I'm going to give you is part of the code. And then if I can trick SQL or any database engine to believe that the data input that I'm giving it is part of the code, then you figured out a way to compromise that database. So in this particular example, I'm not passing it the right username or the right password. I'm just literally going in and grabbing everything I want. So you've allowed, by having something like this, you've allowed yourself to get compromised and let information leak out to the actual hacker of your application. Any questions so far? So how do you protect yourself so you're not as vulnerable to these kinds of attacks? What are you supposed to do? Well, the golden rule is very simple. If you understand this rule, you'll be able to protect your database. The rule is separate your data from your code. If you can turn around and tell the database, here's my code, and then in a second statement say, here's my data, you are allowing the engine itself to protect itself from malicious attacks. If you have no choice, hopefully you do, when you're building an application, you're going to put a lot of your code inside of your application. Why? The DBA that manages the database is not going to, for the most part, allow you to touch their database. It is their responsibility to make sure it's up and it's running at all times. And the last thing they want to do is hand the keys over to someone that just graduated and is learning to write brand new SQL apps. So instead, a lot of people that are starting to write apps will embed a lot of their code right in their application. If that is your only option, you can do a prepare statement. A prepare statement is a way of saying, here's my select statements, select star from table, and you literally tell the database, this is my code, but you physically replace your parameters. And I'll give you samples of this. You physically replace all the parameters with question marks. Second, you make a secondary connection to the database and say, and here's some parameters that I want to use with that code, now execute. What that allows the engine to do is know exactly where your code is at and where your parameter, your data is at. If you do that to the database, you're protecting yourself. Stored procedures. If you're lucky enough, and you push for it, they will let you take a lot of the code that you're writing inside of your application and allow you to store them at the server. Some applications will actually benefit tremendously by this. When you physically store your SQL code inside a SQL, it's like saying, if you're writing Java, you should put it in a Java class. If you're writing HTML, you should put it inside an HTML file. If you're writing JavaScript, you should put it in a JavaScript. You want to do a separation of concerns. Therefore, you do not want to have a single binary that knows all the HTML, all the JavaScript, all the SQL, all of the minutia of getting it up and running. It makes it easier to debug, easier to fix, easier to develop. One of the things that you always want to do is you want to try to take your SQL out of your application and in a stored procedure. What that allows you to do is not only does it precompile the executable or the proc be executing so it runs a little bit faster, what it also allows you to do is say, okay, I'm going to put my SQL hat on and write SQL code as effectively and as careful as possible. You're putting an interface, an API on top of your SQL database away from what your code would normally be. So this way, when you're developing your Java, you're worrying about Java. When you're developing your SQL, you're worrying about SQL. And you're not trying to merge the two together. It makes your programming a little bit easier. Let me show you an example of this one. Let me just highlight this first and I'll come back to the examples. If you are able to move your stored procedures to the database, they are precompiled. You explicitly told the server, this is my code, and these are the parameters. So I showed you a bad stored procedure. Let me show you a better one. So this is a bad stored procedure. It is bad for a simple reason. It is bad because you're still allowing dynamic SQL, meaning you haven't actually told it, this is the code, this is the data. If you want to make this a better one, I'm going to try to make it a better one for you. You get rid of the dynamic. Because you're actually in the environment, you can actually, don't have to put it in a string and have it parsed as a string. You can actually give it the commands that it understands natively. It may seem to be not that big of a difference, but it really is. 2 equals not an assignment. Actually, I like the syntax better. I want to compare 2 values, not assign 2 values, but oh well. If you are writing a stored procedure, you have the benefit of A, you get color coding if you use Stripe tools. You get IntelliSense, so when you start typing in, it shows you the list of objects. If you identify what particular file you're using, in other words, if you actually have alias the name of the table with an A dot, you get the list of the actual field names. So now you're actually taking advantage of the actual platform that you're using. You're getting more tools to help you do this right. You're not trying to concatenate a string and execute it. You're trying to specify, this is my code. And it identifies this as code because it identifies this whole thing as code, and it's going to identify this parameter as a varchar 25 and this parameter as a varchar 200. What you've physically done is you made bad code to slightly better code. And why it's better is because you went away from passing in a dynamic string that just gets concatenated at runtime to something that's static and says, no, there's a separation. Does that make sense? What you guys have done if you do a stored procedure. You've taken it out of your code, you're taking it out of your Java class, you're taking it out of your scripting language that you're using, and you're placing it into the database, and you're pre-compiling it at the server. That's all nice, but what you really have done is you said, this is my code, this is my data. So when you execute the commands, you're not going to be able to, just take the exact one here, because it's the exact same signature. You're not going to be able to compromise it. Ways you can't compromise it, it already understands that even though there's the word or in there and the 1 equals 1, it's not going to try to take that literally and try to treat it as code. It's going to say, no, that whole thing is a string. That whole thing is a parameter. It's going to take it literally as it is, place it right in here, and try to find a username or 1 equals 1. You won't find it. But that's what you're trying to do. You don't want it to try to misinterpret what you gave to it. And that's the whole beauty of doing stored procedures, is that you finally give yourself the ability to separate and declare what is code and what is data. Any questions on that? Come on, guys, no question. Maybe you don't have the option to do stored procedures. Sometimes they'll tell you no, and you don't have access to the database. Well, you can use the prepare statement. We'll cover that right now. And the prepare statement allows you to do something similar, but it allows you to try once again to tell us the engine what is code and what is data. Actually, I want to cover one more first. So this is what you're trying to do. You really, really want to try to do that one way or the other. Let me cover this one. Data link. Data link is a very simple way to attack. You turn, most of the time when someone declares dynamic SQL, they're going to declare a buffer of yay size. If you can turn around and pass me a parameter that overrides that buffer out here, then I can ignore the rest of the syntax. Give you an example. In this particular one, once again, I'm using dynamic SQL, but I've only allocated 100 bytes for this SQL command to be parsed. Now, that can be here in a short proc, and that can be in your code. You've only allocated yay space, thinking, you know what, a username should not be more than 100, a password should not be more than 100. You know, it's never going to be more than 100 characters. And because of that assumption, you define what the buffer size is. So now I want to attack you. And because once again, using dynamic SQL, you're not really telling the server what's code and what's not, what I'm going to be able to do to you is I'm going to pass in a password and then just keep going. Down here, you should be able to see. I knew it was 100, so I'm going to pass in 50-something characters. Why? Because I want to overflow your buffer. And if that didn't work, I'll go to 200. And if that didn't work, I can go to 300. And all that is I'm putting a whole bunch of spaces at the end of it, which you're trying to overflow your buffer. If I can overflow your buffer, then I can still get in, even though I don't know what the password is. But how that worked, let me show you how that works. Here I have a physical buffer of 100 characters. Here I have a command that's taking up some of that 100. Here I have a username and a parameter. But I don't know what the password is. I have no idea what the password is. But if I don't need the password if I can overflow this buffer. If I can take more than 100 bytes, I can knock off that and out of there. And if I can knock off that and, I won't check the password. So what I did here is I passed up enough space so that as soon as this is done, I'm actually right here. Once again, what if I didn't know that it was only 100? I could have tried 150. Could have tried 200. I'm overflowing your buffer. Once I can overflow your buffer, I can compromise your original intent of what you were trying to do when you were trying to send that command to the database. How to use it correctly? Supposedly, I'm always going to use the right username and right password. So if I use the username and password, yes, it works. But you know what? I don't have to have the right username. The right password, I can just overflow the password part of it and just bypass it altogether and still get in. That's a buffer overflow. Not only do they exist inside of your code, they also exist in the database because as programmers, we're trying to be cheap as to what our resources are. You don't have endless amount of memory, you don't have endless amount of anything, so you always try to define the certain sizes of certain things. The problem is when you do that, you expose yourself to allowing input to be more than you've allocated for. So a simple thing I could have done to protect myself is be more realistic about what I'm going to allow in. I mean, honestly, if you know you control the actual schema of the database and you know that you created a user column of 25 bytes total per user, why would you want to accept 100 characters in for a parameter? If you know that the password hash is always going to be 30 characters, once again, why would you accept only 100? If you know that the actual commands all contained together might be yay long, then you may want to control the size of your buffer. Cool. This is the hard one. I learned this the hard way. All user input is evil. I don't care what they tell you, it's evil. If you turn around and you take input from a user and you do absolutely nothing to validate, you take that information and you pass it to your database, then it's your own fault. If someone says, what is the quantity you want to order for this application, and you allow 1 million as the value, because you're hoping you can sell 1 million widgets, shame on you. You know you're not going to sell 1 million in one line item. Make them do 10,000 per line item. You can still sell the 1 million, but you control the range. If you use dates, if you know that you're going to make an order date for some date, don't allow them to have it ordered yesterday. So you need to turn around and validate the data. If you can validate the data, then what you're actually saying is, look, I expect a number here. and it needs to be a number, and it needs to be within its range. If you start doing simple tests like that, you're going to mitigate how much crap gets to the SQL database. So even if the SQL is not fully protected, by you turning around and preventing what is going to the SQL database, you're preventing how much damage can be done to the database. When you do a web app and you do not define the length of the actual input, how many characters can you type in, guys? Anybody know? You do basic HTML, you put an input tag, you did not specify maximum width, anything, you just let the users type. How big of a string can be sent up to the server? Any guess? You can send 2 billion records, 2 billion bytes. That's 2 megs. I'm sorry, billions is a little bigger. You can send 2 megs up per input. And if the person says, you know what, I don't want to use a browser, I just want to attack you, so therefore I'm going to write custom code to send data to you, and you have done absolutely nothing at the web part end to prevent, you know, 1 billion bytes to come in for one username, then that's what you're going to send to the database. So it behooves you to say, all user input is equal. Whenever I ask for a parameter, whatever that parameter is, it has to have a certain range. If it's a date, I want the date's range to be yay. If it's an integer, I don't want more than 10,000 apples at a time. If it's a string, which is concatenations of strings, then you control the length. Not every string has to be that big. Oh, it's a nodes column, hey Susan, because it's a nodes column, I want the user to be able to type what they want. Okay, let's be serious. You may have a nodes column, but you're not going to have the person write the good, bad, and the ugly, or a brand new novel of the good, bad, and the ugly in one small little section. So be realistic. If you're going to give them a notes box, maybe 1,000 characters, and maybe with the option to add a secondary note with another 1,000 characters. The idea is simple. You don't want to allow unlimited strings to come in. If you can allow an unlimited size string to come in, that means the person attacking you can be as creative as they want when they send a command on how to break into your SQL. Does that make sense? Show you one more bad one here. Okay. This is the person trying to make it a little bit better. Didn't do well, but they try to make it better. The database engine knows how to prepare a SQL statement. To prepare a SQL statement, this particular version of SQL Server uses SP Prepare. It also does SP Execute SQL, but whether you're using Oracle, whether you're using MySQL, they all have a command that allows you to specify what's code, what's parameters. So in this particular syntax, it's saying, I want to prepare the SQL statement, and I want to treat this as the code, and I want to treat these as the parameters. Let's scroll down some more. You'll see what the actual parameters being sent are. So here's your parameters. So what you've done at this particular point is you've explicitly said, here's my code. By the way, in this code there are these parameters, and here's the value of those parameters. You're allowing the engine to protect you from yourself. The reason I show it here is not because I would actually put this in a short procedure, but because you would actually put this in your application. Your application itself should, if you are going to have dynamic SQL in your app and you have no choice, you should be preparing it. You should be telling the database, here's my code, here's some parameters, and by the way, here's a value for those parameters. If you do follow that and you try to turn around and hijack it, that's the right username and password, it's going to work, but now I'm going to pass the same hijack as I had before, and it's not going to accept it. I mean, these are identical. The only difference between this one here, bad one and bad, it's the same code. The difference is this one's using a literal execute. The literal execute says, just take it as it is, execute parse the whole string and execute it. When you send something from a web browser to the SQL server as a literal string, you're literally just saying execute this string. So try to figure it out, try to parse it for you, to try to give me my results. In this particular, the second one though, it's saying, no, I'm not going to just give you a literal string. I'm going to be explicit to tell you, this is the code that has parameters, and these are the value for those parameters. You try trying to protect yourself from any kind of injection or attack that is going to be hitting you. And you might say, well, who's going to attack my little application? You know, I don't make them that big. It doesn't matter. If someone can exploit your database to control your box for some other purpose, you know, you're just one of the pawns they might use for a bigger attack. So just because you're small doesn't mean you won't get attacked. It just means that you won't know that you got attacked. Any questions so far? Another thing you have to be careful for, someone's trying to attack you. If I'm trying to attack you, one of the things I want to know is this person using a SQL database? Is he using an Oracle database? Is he using a MySQL database? I mean, what kind of database is he using? So not only do you have to be careful of what kind of crap you allow in, you have to be careful of what you allow out. If you turn around and you pass in an extra quote or extra character, and you turn around and you crash, and it tells you, oh, the syntax that you gave me was bad, and it's telling you this is a SQL Server box. Well, you're giving the attacker too much information. You're telling them what version of the database you have. Many times it actually has the actual, depending on the error code, it actually also specifies what the actual patch level is of that base. So now I know what database you're running. I know that you're running Service Pack 1 or Service Pack 2. I'm going to go look for common exploits to say, oh yeah, I know that particular database has an exploit. Microsoft published it. I'm going to use that to attack you even easier. The point is simple. Don't tell people more information than they need to have. Just like you have to be careful of what crap you allow in, you have to be careful not to allow that to go back out. If you're going to get a main error, don't give it to the user. Report it. Send an email out. Tell the user there's a problem, but there's no reason to give them the whole spiel of the database of what the errors are. There's a good chance that your user is not a programmer, and he's not going to be reading the details and call you up with the answer of what you did wrong. You know, so why give them that information? I didn't think I was so fast. So, for money, who can tell me what is SQL injection? What is SQL injection? What is literally, what is it? It's me trying to manipulate the strings you're sending to the database and putting my code in there. I can give you 100 more examples, but they all are the same thing. It's me finding a way to compromise the string you're passing. If that's all it really is, then what's the fix? Anybody else? If the actual manipulation is me being able to manipulate the commands you're sending to the database, if that's the bug, what's the fix? Validate before you send crap. What else? You got to make sure you tell the database, hey, this is my code, and over here's my data. Because now not only are you validating to make sure you don't give it crap, you're giving the engine an opportunity to say, this data over here, don't try to interpret it. Don't try to execute it. It is data and is not meant to be executed. If you make that simple separation, the number of attacks, the surface area of your attack, just went down significantly. Does that make it 100% proof that you won't get any kind of SQL injection? No, but it takes it back down really small. Because if the main attack is the fact that I'm manipulating strings, then removing the ability to manipulate the strings mitigates a lot of that attack. The validation is very, very important because if you validate your data, there's no reason it needs to go to the database. If the guy gave you garbage as an input, why do you want to hit the database with that? You ask for a number, he put in John, throw it out. There's no reason to pass John to the database. But you only know that when you validate prior to passing. That's why validation is extremely important. If you can use stored procedures, once again, you are formally announcing to the engine, this is code, this is data. If that's an option, that's why we use stored procedures. Sometimes it's a little faster, who cares? Sometimes it's a little bit more easier to manage, who cares? The main reason you're doing it is to protect yourself and the users of your application from any kind of compromise. Dynamic SQL is a generic term. SQL is the commands that you're sending to the database to interpret, to do something, to create a database, to create a table, to select data from a table, to update a user, to do whatever. That's SQL. Those are commands you're sending to the database. Dynamic SQL is what allows you to change, based on input parameters that are coming in, different commands can go to the database. Why you need dynamic SQL, otherwise your app is worthless. You don't necessarily allow it to change its execution. What I mean by execution is, if you have one store procedure that simply does one thing, returns back a list of products, don't try to make it do more than that. Many a times when you're making your development, you don't want to develop the same web page twice. You say, well, I developed this grid, and it always displays a list of blah. And because it displays a list of blah, you made it very intelligent so that it's going to look at the columns that you gave it, and it's going to actually dynamically list the columns. It's going to look at the types, whether it was a string, whether it was an integer, whether it was a date, and dynamically list them. Well, you're thinking you're saving yourself a lot of trouble, because now once you make this grid, it doesn't matter what kind of SQL return data came back, what results that came back. You can display it all. You never have to make that grid. Isn't that great? The problem with that is somebody compromises you, and they turn around and selected more data from the table instead of crashing and dying. It's going to dynamically look at the number of columns, dynamically look at the types, and dynamically display to the user in a nice, pretty grid. So, yes, you need to validate. Yes, you need to not report and expose yourself as to what you're actually using as far as the backend, what the parameters, values are valid or not valid. You also don't want to make it so generic that you don't have to program, but you allow the attacker to pull data from your database that easily. So one way you're saving yourself some programming, and the other end, it's very easy for them to attack you. Be specific. If you know that this purpose of this one particular application you're doing, this particular page you're doing, is display the score on last week's test, do that. Don't do 20 other things, just do that. You need to change it, you need to change a small amount of code, because that's all you did. When you do more than what you're supposed to do with it, then you have to debug it and troubleshoot it a lot more often than you need to. So my main summary points of what you want to do to protect yourself if you want to mitigate the SQL attacks is separate your code from your data, validate, validate, validate. If it's crashed, don't even send it to the database. It should be validated before you go anywhere else. Try to use store procedures. Sometimes you have no choice. You try to limit how much dynamic data, dynamic SQL goes to the database. And for God's sakes, don't help them. They're there to attack you. And the last thing you need to do is give them help how to attack you. So therefore, when you do get errors, and they will happen, don't just dump them out to the user. Don't expect them to read it for you. That's lazy. Send it to yourself, write it in a log, and notify the user there was an error. But there's no reason to give them the full details of where it crashed, what version of the web server you're using. Is it Apache, is it IIS, are they using MySQL? That's none of their business. You don't want to expose that. But most hackers use that as tools to attack you even further. Because now they know what version of Apache you have, and they know that that particular version that you're using has this vulnerability, and now I know how to attack you a little bit better. I like books. These two were, for this particular session, very helpful. SQL Injection and Attack and Defense. Lots of samples, lots of solutions how to fix it. But if you read the book cover to cover, you'll come out with 4 basic ideas. Validate your user input, separate your data from your code, don't help the users attack you, and limit your dynamic SQL. You should get the books because they're good references and they have really good examples, but that's the core. That's what you need to do. And you're not just protecting, when you protect the database, you're not just protecting one application. As you all know, most web applications that you access now are accessible from your PC, from your Mac, from your phone, from your iPads, from most devices. So when you're actually protecting the database, you're protecting it from all those devices. So it is very crucial that you do protect that, because you're not just protecting one app, you're protecting all the potential apps that will be attacking your database. Once again, my name is Jesus Rubio, and I want to open this up to any questions and answers you guys might have of me.
On the validation, can you just let it eliminate certain characters? You know, if you can't put any signs in the
What do you guys think? Let's get rid of all single quotes, because single quotes allow me to bypass a few things. Would that work for every solution? What do you guys think? No. Mr. O'Neill would not be very happy with you. Sometimes you have no choice. You have to leave the single quotes. But then you'd say, oh, okay, so how do you handle single quotes? What would you do if you want to pass in an O'Neill? Well, if you had a single quote, you could pass in, and you pass in a parameter, an escape. An escape tells the parser, oh yes, anything after this, I want you to take it as a literal. Don't try to parse it, take it as a literal. Okay, that's true for SQL, but well, what about if I'm using MySQL? Well, then you have a slide. What if I'm using Oracle? What if I'm using, and all of a sudden, because you might be using different databases in the back end, you have a whole bunch of if statements trying to determine what the back end is and what the proper syntax break is. It's much easier for you to say, this is data, this is code. Treat this as data. It doesn't matter that there's single quotes or there's no single quotes, this is data. Don't try to parse it. If you do that, you don't care that it's O'Neill. You're literally treating it as data. So the idea of, no, let's just get rid of single quotes. Let's get rid of, don't allow dash dash. You know, I don't want any dash dash because then they can do a comment. And if they can do a comment, they can bypass my code. So I'm not going to allow dash dash. And then some user that you have using your application says A minus B, but it won't store the minus. I wonder why. Because you disallowed the minuses. So once you get into that, you end up, you're thinking you're doing the right thing, because you're minimizing the exposure, but you're actually limiting the application of what you need to do. What you really need to do is tell the database, this is my data, this is my code, don't treat them as one and the same. Any other questions? Come on, guys. Anything at all?
Let's say you separate the data and show algorithm. Is it possible to still do an SQL injection?
Yes, but at that point you're talking about vulnerabilities on the engine. So an example would be this one. In version, in SQL Server 2007, certain characters, certain syntax, always executed. So therefore, even though you separated the code from the data, but you would have passed in and it would try to execute it. It says, oh, hang on, that's declarative. You know how when you turn around and you make conditional code in your Java? When you do conditional code, you're actually talking to the compiler because it's declarative. You put in your pound sign to say this is a declaration that I want you to look at prior to looking at my syntax of my code. SQL has the same concepts in which they have declarations. Some of them start with the at. And what you're telling the actual engine, hang on, this is not just SQL, this is a declaration that I want you to consider. And once again, when it sees those types of declarations, even though you told it, this is data, this is not code, it's going to look inside and say, oh, but I see a declaration, all bets are off, I'm going to execute that. So the point is, if I did Ulster procedures, would I never get a SQL attack? No. You minimized how often you're going to get attacked, but unless you're patching up that box to the latest whatever, then no, you're still exposed. What even sucks even more, Microsoft wants you to publish and wants you to patch up their boxes. If you bought it, you need to patch it up. And one of the things that happens to them from time to time is they get reported that they have a specific vulnerability in their database, in their OS, in their Exchange, and what have you. For a while, it's kept under wraps. For a while, they're able to keep that quiet. But once Microsoft identifies it, fixes it, and produces the patch, then all bets are off. The patch is out there. It's been out there for a month. Here's the results. On their own website, they will tell you these are the vulnerabilities that we fixed with that patch. Well, for me that put the patch in, that's great. I patched it, right? But for you that haven't patched it, Microsoft just told the hacker how to attack you. Well, why would you do that for? Well, I told you, here's the patch. Why didn't you patch your box? The idea is that not patching your box allows for certain vulnerabilities to be attacked, certain vulnerabilities to be exposed. So that's not something you control as the DBA or the programmer. That's something that other people need to be responsible for. But at a minimum, you as a DBA should be able to say, look, you know, I want my app to be successful and I want my app to run and I don't want to be exposed. Can you please take it off of SQL 4.2? You know, there's several other versions we can move up to. So that's kind of back and forth. Any other questions? Yes? Yes, yes.
I'm new to SQL, so I'm taking a class in SQL Server. And I'm glad I came to this because tomorrow we'll be talking about SQL, procedures, triggers, and all that. And I was just wondering, if
Absolutely.
supposed to be a major project to avoid.
So what is the
All things
opposite?
you can do,
What is the opposite of security?
you know.
What is the opposite of security? Convenience. Convenience is the opposite of security. I can lock the doors of my house, but then every time I have to go to that house, I have to unlock it again. I can lock the doors to my car, but every time I use it, I have to have a key with me. Well, the opposite of convenience is security. So you say, if dynamic SQL is so powerful, but it's so vulnerable, why do we use it? Convenience. It's easy. I can just embed this SQL statement in my code, execute it, get my results, and I'm done. I don't have to think about it. I don't have to consider the consequences of future growth of this application. I'm just going to make a little table or write a little ASCII file, and I'll put all my SQL commands in there, and I'm going to just read them, parse them, and send them on their way.
Are there situations in your experience where you have to use dynamic SQL because there's no other way of doing that?
When you try to force the database to do something it was not designed to do, pivot tables being an example, you have to use dynamic SQL. So an example would be, I want to run a report, and the data is all, most table design is going to run the data downwards, in which you want to get a list of states that have more than 100,000 citizens. You can actually run it, and it will give you the states this way. Well, somebody at one point in time was going to say to you, I don't want to see it running vertically, I want it horizontally. So you have to pivot it. Well, how do you pivot in SQL? Because the original design of the database was always designed to go this way. You're going to have to turn around and write dynamic columns. So therefore, you're writing dynamic SQL to actually create columns. Because normally speaking, when you write your code, let me show you this. Normally speaking, when you write your code, you're literally going to say, hopefully you don't use star. Select last name, first name, date of birth. You're going to specify the columns you want. So you're actually telling the engine, I want you to make me a result set, and I want you to use these columns. Normally that's how it works. But all of a sudden, because you don't know how many columns you have, then you're forced to use dynamic SQL because it's a variable number of columns depending on the results. So there are situations in which, yes, you do. You might say, oh, the latest version of SQL Server has a pivot function. It works, but you still have to use semi-dynamic because you have to go figure out how many columns you want still. So there are situations, even with this database, that you do have to use something dynamic. So do I say get rid of it altogether? No, because you can't. Depending on what the user is asking for, what reports you have to report on, you may not have the option to get rid of it altogether, but you definitely can mitigate how often you use it. You don't want to use it really for everything you do. But even if you do use dynamic SQL, if you are using Java or .NET or even C++, the API that's given to you, the library that's given to you to talk to SQL, 99% of the time will have a prepare statement. The prepare statement is for you to be able to tell it, once again, this is my data, this is the SQL statement I'm about to run. We give you that first. Okay, now here's parameters I'm going to give you. Okay, you have that second. And now here's the user input. You're giving the engine a chance to protect itself. That is much better than just concatenating a string and giving it all to it once and say, figure it all out for me. It's a lot easier to say, here's a string and make it work, because when we develop, we open up iSQL and we start typing it in. And that's how we learn to create tables, to create procs, to make views. You do it all inside of an editor and just try the command. And once the command works just the way you want it, what do you do as a programmer? Highlight, copy, code, paste. And now you've created dynamic SQL in your code. That's the whole problem. Take a few more steps and say, here's my code, here's my parameters, here's my data, prepare, execute, send parameters, execute, and send it. And the nice thing also about when you do the prepare is it gives you back a handle. So you can execute once, twice, 3 times, 1,000 times, and it's been pre-compiled so that the execution is a lot faster. Any other questions? Well, that's a good question, thank you.
We didn't see the titles of the books. We took them off the screen so fast.
Oh, I apologize. These are actually good books. One is called SQL Injection, Attacks and Defense by Justin Clark. The other one is Denny Cherry, SQL Server, Protecting Your Data from Attackers. if I really wanted to attack your site, I wouldn't limit myself. If I use a browser, I limit myself to only being able to attack you through the query string, the form, and the headers. But if I really wanted to attack you, I'm going to actually just write a little bit of code to start sending queries directly to you. So I can do buffer overflows and what have you. The reason why is the browser in itself is trying to protect itself, so the amount of data that I can send to you is limited. I don't want to limit myself, I want to attack you. So therefore you might say, well, hey, Jesus, if I'm within this browser, what other ways can I attack? You can get rid of the browser. If I can open up a TCP connection, TCP IP connection to you, if I can open up a socket to you and send you information, I can turn around and say, get HTTP, and here's my body, here's my payload, and that payload is limited only to what I can think. Does that answer your question?
Yeah, is there a way to look at that?
Yes. Validation at the server level is the only other way. Because I can send you a whole bunch of crap. TCP IP, open a socket, here's a megabyte. I can send it to you. On the other end, it can say, okay, I'm going to allow a maximum buffer size of accepted input of 0.5 meg. Anything above that, I just won't accept it. I just reject it right there and then. What you've done at that point is you've hardened the server so that you limit how exposed you are. And that's a little bit further, but the idea is the same. Don't allow garbage in. Any other questions? Well, thank you. That's all I have for tonight. I hope you enjoyed it a little bit.